2019 AP Micro FRQ, number 3, Oligopoly from 2019 was very tough. The whole 2019 test was absolutely painful. Let's look at it here. Let's say Patrick Pie advertises. I've already underlined all of Patrick Pie's numbers. I've squared in all of D's numbers. This helps me keep everything straight, I think. Then I've written a little word chart here. If Patrick Pie advertises, what's D going to do? Let's go ahead and do it. If Patrick Pie advertises, D has two choices, either to enter or to stay out. It looks like staying out, 0 is better than a -2. So stay out because 0 is greater than -2. If instead Patrick Pie does not advertise, D only has two choices, to either enter or stay out. It looks like entering is better because $15 is greater than 0. All right, let's clean this up a bit. Now instead, let's say that D decides to enter. Patrick Pie has two choices, to advertise or to not advertise. So they're going to choose to not advertise, as 150 is greater than 50. Instead, let's say that D chooses to stay out. If D chooses to stay out, Patrick Pie can either choose to advertise or not advertise. It looks like advertising wins because 175 is greater than 100. Now recognize that nobody has a dominant strategy. When there is no dominant strategy, it gets tricky because there can be 0 Nash equilibriums, there can be 1, or there can be 2. All right, let's see if we can figure these out. Let's go back in. Let's clean this up a little bit so we don't have all of these all over the place. And okay. Now let's read it. Once we know what everybody's doing, right? We've underlined, we've squared in, we've got it all set up. Then we say, what actions maximize the combined total profits for Patrick Pie and D's Pizza? When they say what actions, they means what quadrant are they going to end up being in. We just have to add up the numbers on the different quadrants. This is 175. This is obviously 48, 165, and 100. This quadrant is where profits are maximized if they were working together. So we would say that Patrick Pie advertises while D stays out. Patrick's Pie would advertise while D stays out. And we can see that Patrick Pie's profit would be 175, whereas D's would be 0. But that's better than -2, so... and that's what they're asking for B. Conditional on your response in part A, does either Patrick's Pie or D's have an incentive to cheat on this combination of actions that does maximize the combined total profits? Explain using numbers from the matrix for each party. All right, so let's make sure we understand what we're doing here. And that, is there a reason for Patrick's Pie to choose anything other? If D stays out, Patrick's Pie's choices are either 100 or 175. Obviously, 175 is better than 100. If Patrick Pie advertises, D's choices are 0 or -2. They're going to choose the 0, right? And we can see that up here. If we looked at these two, it looks like when D stays out, Patrick's Pie would advertise, so these would be numbers we use. And then when Patrick Pie advertises, D stays out. These two are this Nash equilibrium right there. So we would just give these numbers, right, this sort of reading. When Patrick Pie advertises, D stays out, and when D stays out, Patrick Pie advertises. This is one of our Nash equilibriums right there. Because they have no reason to move anywhere else. When one makes that choice, the other one will make that choice. And when D stays out, Patrick's will always advertise. That is our Nash equilibrium. since there is no dominant strategy, it just depends on who goes first and which one chooses what, as depends on where they end up. All right, I hope that's clear. And let's get rid of these, and I want to get rid of that. All right, back to normal. We can see here, it just says, does Patrick Pie have a dominant strategy? We can see that Patrick will not advertise when D enters and will advertise when D stays out. So there's no dominant strategy. Sorry about the plane. They don't ask us to explain, we just have to say no dominant strategy. Identify the Nash equilibrium or Equilibria actions for this game. This gives us a little hint that there's probably more than one. And there is. We know these two, let's say 1 and 4, are a Nash equilibrium. So then we got to get a little suspect that maybe 2 and 3 here are also a Nash equilibrium here. And let's check it out. If Patrick Pie does not advertise, it looks like D's Pizza is going to enter. And if D's enters, Patrick Pie would not advertise. So this is also a Nash equilibrium. Using those numbers, we could explain why that is a Nash equilibrium. So we had 2 Nash equilibria in this problem. Tricky. Let's read E, because E absolutely floored me the first time I read it, and I had no clue what they were talking about. Let's redo it. Let's see if I can move that up just a bit. I can get it. There we go. So let's redraw the matrix and talk about what they're saying here. Suppose that Patrick pays D's $20 if D chooses to stay out. So let's just stop and recognize what's going on there. When Patrick Pie, there's either advertise or not advertise. When D chooses to enter or stay out, Patrick is paying D to stay out. So we would take from the 175 up here, right? When Patrick Pie pays D to stay out, the 175 goes down to 155 because $20 has to go to D. And the 100 would, the 100, can I back that up? Yeah. Would turn into 80, and that 20 extra dollars would go to D staying out. So now D has 20 bucks in the stay out categories, right? Let's square them in so we know what we're talking about. Underline. These are not affected, 50 and a -2, and 150 and 15. So now we've got our chart redrawn, recognizing whose numbers are whose. Underline, 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 square out. And it says redraw the matrix. We've done that. Identify the Nash equilibrium for the redrawn matrix. Now again, for that, I would do another word chart. I know. Some people can do it really fast. I'm like a child, and I do these again and again just the same way, so I don't make any mistakes. Still make us mistakes, but do the best I can do. This cuts them down. Now D can either enter, and Patrick Pie will choose something, or D can stay out, and Patrick Pie will do something else. So when Patrick Pie advertises, D would choose, obviously, to stay out, because we can see 20 is better than -2. -2. If Patrick Pie does not advertise, D will obviously choose to stay out, because 20 is greater than 5. If D enters, Patrick Pie would not advertise, because 150 is greater than 50. And if D stays out, Patrick Pie would advertise, because 155 is greater than 80. Can we see that? So we do know somebody who has a dominant strategy. They will always do the same thing no matter what Patrick Pie does. D will always stay out. So if D stays out, Patrick Pie will choose to advertise, and that becomes our Nash equilibrium. There's no reason for anybody to move unilaterally from that spot. All right, guys, I hope that helps. Be safe. Take care.